To solve a system of equations using elimination, we first multiply both sides of one equation by some constant that will cause a variable term to cancel out. Sometimes we need to manipulate both equations. Step 2, add the two equations together so that a variable is eliminated. Step 3, solve the resulting equation for the variable that remains. 4, use the new known value to find the value of the other variable. And 5, check the answer back in the original system. Our goal here is to eliminate one of the variables by adding the two equations. Notice if you add right now, you'll get 3x. The x's don't go away, and you'll get 3y. The y's don't go away. So we want to pick one of the variables to eliminate. If we pick the x, in order to add these and make the x's disappear, we'll have to multiply the bottom equation by -2. If you wanted to eliminate the y's using addition, we would have to multiply the bottom equation by 4. If we have -4y here and we added, the y's would go away. I'm going to choose to eliminate the x's. We have options, so I'm going to multiply the bottom equation by -2. We don't need to change the top equation in this particular example, but we could if we needed to. So again, we're going to multiply the bottom equation by -2. And notice now when we add the equations, what happens? 2x plus -2x goes away. 4y plus 2y is 6y, and 5 plus -8 is -3. Divide by 6, and we get that y is equal to -1/2. Now our goal is to find x. We can plug y, the -1/2, back into either of the original equations. It doesn't matter which one we use. I'm going to use the bottom one, simply because it looks easier. So replace the y with what we found for y, -1/2. We get x plus 1/2 equals 4. We then need to subtract 1/2 on both sides, and we get x equals 7/2, or 3.5. The answer is a coordinate, 7/2, -1/2. If you wanted to check your answer, you could plug x and y into each of the original equations and make sure we get a true statement.